Okay, well, I'm Mike Morello. I'm the editor and publisher of Utility Horizons International e-magazine. We're the first and only all-digital magazine for the electric, gas, and water utility, automation, and information technology marketplace worldwide. I've been an independent consultant for 32 years. Also have a research company along Kinectrics, and been involved in the energy and utility fields for literally my whole career. So met everybody at least twice. Today we have a panel here to talk about sustainability and computing in the cloud. To my immediate left is Andrew Wright. He's the CTO. Well, actually, I'm going to let everybody introduce themselves, but Andrew's the CTO of a company called End Dimension Solutions. We have a pretty eclectic mix of people here as far as their walks of life professionally. Andrew is a cybersecurity expert, which is, of course, a critical component of anything we do in the computing area. Next is Michael Nark. Michael is the president and CEO of BuildingIQ. And to his left is, how old are you again? Paul Lekan. And I've been friends for a long time. Met Paul when he was at Clara. He's now UTC. And on the very end there we have Steve Winstead with Leidos.
Yeah, I've been with Leidos long enough.
You get your name on the wall, right?
Back in its former incarnation, that's for sure. Yeah, 31
years.
years with the equivalent of it.
So we have people with a lot of experience in diversity here. So the way we're going to do this is that even though we're cut a little bit short on time here, I apologize for that, but unfortunately the midday sessions went long again. What we're going to do is, my definition of a panel is not to have 5 people or 4 people make presentations instead of 4 individual presentations. There will be no presentations. We're just going to talk, and I want this to be as interactive with the audience as possible. So we're going to dispense with any long, flowery introductions. I'm going to let each of our panelists just say a few words about who they are, what they do, who they work for, what their vision, mission is, essentially. And then once we get through that, I'll throw out an initial question for our panelists to each address, and kind of get everybody's juices flowing, get your brains working, everybody thinking. And at that point, we're going to start expecting there to be questions from the audience. So be thinking about, you have some expert people here, you're able to pick their brain, take that opportunity. So we'll go ahead and start with Andrew.
Okay, thanks, Mike. So again, Andrew Wright, CTO End Dimension Solutions. We're a cybersecurity for utilities products and solutions company. So I'm not a utilities person, but I've been doing control system security and utility security for well over a decade now. I lost track. It just happens that over the past 6 months, we've been building a new security service that is partly appliance-based at the utility and the utility network, partly cloud-based, and partly managed service. So we've been dealing with a lot of the security issues of this service. How do we make sure the appliance is secure? How do we make the cloud piece is secure? How do we ensure that the connection between all that is secure? How do we ensure that the people who have access to it are the right people and not the wrong people? So I can speak to a lot of the security issues around what it takes to build a secure cloud service and how you can screw up the security of cloud service.
Steve and I had the pleasure of earlier today being with Mike on another panel, and it was early in the morning, so it was the nomenclature was slightly different. So anyhow, I'm Michael Nark from BuildingIQ, and like Andrew, I'm not a utility guy per se. Obviously, utilities represent a customer opportunity for us. Quite candidly, what we really truly are focused at is actually inside the building itself, and essentially controlling and managing energy expense and energy usage through better optimization of heating and cooling of the building. And we actually do that by leveraging automation from the cloud. Hence the reason for me being, I think, on this panel is the fact that we actually actively do two-way communication and control from the cloud down to the building to change the amount of energy it uses from the heating and cooling perspective. So I'm happy to be here and look forward to the next half hour, 45 minutes or so.
My name is Paul Lekan. I'm with Utilities Telecom Council. I actually initially objected to the distinguished. I kind of like eclectic.
I made a note.
Yeah,
I've been called both today, so.
You could do worse. I'll start by saying Utilities Telecom Council, I represent utilities. We're a trade association based in Washington, D.C., with facilities and programs in Canada, U.S. I'm looking through the map in my head. I'm a right-brained person. Latin America, we've recently opened up in the process of opening up in Africa, and then we have an established group in Europe as well. So we're a global presence. Our utility members are gas, water, electric utilities, as well as a few other transportation, pipeline, critical infrastructure utilities as well. UTC's been around for a little over 67 years. We support the ICT community inside utilities, information and communication technologies. It's the IT-OT convergence element. We have active, engaged board members and members who range from CTO, CIOs from some of the largest investor-owned utilities to field telecom engineers to some of the smallest co-ops and munis in the world. So very diverse group. Our core mission is actually delivering the data that we talk about and everything throughout this conference. Our members they wake, breathe, eat, sleep, developing network technologies to deliver data. That's what they do securely and efficiently. And in the last 15 years, I think it's been fairly obvious that data is what's going to deliver the energy. Data is the fundamental equation in delivering energy and water resources to not just locally, but globally. So that's what our members keeps us up at night. Our practice involves, of course, technology issues, education, training, access. We also have a fairly sophisticated advocacy and regulatory support body of work. And we're also a frequency coordinator for utilities for FCC licensing. And we have a rapidly growing cybersecurity practice and supply chain security practice. I'll say security practice that focuses on making sure that our utilities have the resources to make this a secure enterprise. So that's UTC.
Thanks, sir. I'm Steve Winstead with Leidos Engineering. And let's see, I'm starting out, and let's go from the angle of I'm a senior systems architect. And I don't know how much you know about Leidos, but Leidos used to be called SAIC, another name you probably never heard of. But we've been around for a long time doing a lot of things in the commercial business space with utilities, from generation, transmission, distribution, customers, you name it, and we've been involved in some manner or form. The perspective that I'm bringing to this table is to one of a systems integrator. In other words, we've seen a lot of different systems. We work with a lot of different utilities, worked with IOUs, munis, co-ops, support organizations for those, and basically seen a lot of different things, and things work and things that do not work. I've got a different perspective on maybe from some of the gentlemen here on board is that, we're looking at real world solutions as far as what works in the cloud, what doesn't work in the cloud, what still makes sense on the dedicated platform, what some of the real world things that we run into. So hopefully I'll be able to share some of those things with you. And we just recently completed a study to where we did next generation IT architecture looking at 20 years. And one of the big things was right now is people in the utility space, in this case cooperatives, what the situation is today and what's the propensity about going to a cloud and why should they do it. So we took an honest look, did some survey work, so I've got some data that we can talk about in that regard.
I don't know how many of you have caught the Tom Siebel presentation. Everybody else does that? Yeah. Well, you heard him say toward the end of his presentation that he said, if you're a utility person, he said you probably have data centers. He said, I'm here to tell you that in 10, 15 years, you may still have a job or you may not, but you won't have a data center. That's a pretty profound statement, and I suspect he's probably right. Data centers are the fastest growing and biggest users of energy on the planet, and there's no end in sight. I mean, the whole move to cloud computing. He also talked about the fact that there are certain things being done in the analytics space that you cannot do in your data center. It requires cloud computing because you need huge arrays of computing power to be able to do it in less than a lifetime. Really difficult stuff, very complicated software and so forth. So, with those thoughts in mind, the fact that, that's where it's going, that it's going to the cloud, really the importance can't be overstated. Amongst ourselves, traded some ideas and thoughts back and forth about questions and topics for this session. And one of the ones that I wanted to start with that really bubbled to the top is, you know, with any new market area, cloud computing, sustainability, or no exception, people need to understand the fundamentals. And the fundamentals start with definitions of terms. And the one that came up here that I think we want to start with is the difference between security and privacy. A lot of people interchange those things as thinking that they're the same thing, when in reality they're related, but they're really quite different. So I thought maybe we'd start with that. Steve, you want to jump off with that?
I should say, past life, I worked for a solution provider that provided AMI services as well as meter data management services. We produced portal exchanges for consumer data. I will say that as an industry, when we discuss security, I think we do tend to lump it into one ubiquitous need to protect not only the linkages, not the architecture, protect the data resources themselves, but also ensure that we have some privacy layers as well. I think when we, as an industry, sometimes we forget to acknowledge that our customers, our stakeholders, first and foremost think about my data, what is personal to me. So, and I think that's probably a distinction that's easiest to maneuver around is place yourself within the utility. Privacy and security are very one and the same. It's a breach of personal information or a breach of mass information versus a breach period are both security concerns. In the outside world, it's more protecting what is my identity, protecting what is my data resource. That can extend to within the utility as well, the stakeholders within the utility, the GIS folks. You know, if you've ever worked with utilities under GIS information, that's extremely sensitive data for them. They don't like to share where their assets are they don't want to lose that custody of that information. It's critical information. So when we talk about security, we tend to talk about barriers, defenses, and reactions to, and protection measures. When we talk about privacy, it's really about ensuring that the information is being viewed and accessed by the right person. And they're one and the same internally, but I think externally it's that privacy issue is what really is the buzzword to our customers and to the people that we serve as an industry. And I think we just need to acknowledge that. Even though I can probably log into Facebook and find out that none of you are home, right? And I know that this group has graciously put my face on the speakers list, and everybody knows that I'm in Austin this week. And my house is protected by a very large black Rottweiler, by the way. That's a privacy issue. But if they were able to get into the ETS system and look at my credit card transaction with Andreas, that's that security layer that I think we're talking about.
Anybody else?
Andrew, you should go. This is your good topic on this thing.
Sure. So in the cybersecurity world, generally, we talk about confidentiality, integrity, and availability. We break it down that way. So privacy is sort of more in the confidentiality area and keeping information secret. Integrity refers to are you communicating with some? Has data been changed in a way, either at rest or during communication, in a way that's not intended? And so we care about integrity very much when we're sending control commands out to a breaker. We don't want that control command to be changed along the way, hit the wrong breaker, or be forged by somebody who's got access to the network. That's very different than confidentiality. We don't really care if anybody can see the control command going out to open the breaker, but we care that it gets there or not gets there as we intended. And then availability is whether or not you can, the resource or the communications channel is available. So clearly you want to ensure you've got availability so you can send those control commands to the breakers. And in the typical enterprise network, an office network, this where people live in Word, email, and so on, you care about these things in the order of CIA, confidentiality first, integrity second, availability third. But in a control network, you care about them in the opposite order. You care about your availability, integrity first, much more than confidentiality. So I think a utility needs to look at it from the internal operations side is the AIC order, but when we get to the billing and the customer's data, then we're more back into the enterprise world of CIA.
The only thing I would add to the discussion, which I think is pertinent when we talk about privacy, security, I also think it's important to validate or cross-reference, maybe is the way to look at it, about what we're actually doing with that data. And there's obviously various levels, right, of security and privacy that have to take place. And if we're talking from the healthcare side of things, it's obviously HIPAA-related and specific personal data about people, credit card transactions, et cetera. So we also have to keep in mind the hierarchy, right, of security, and then obviously the wrap around that of privacy as well. And if we bring it back to really kind of this session, right, which is driven around sustainability and automation, quite candidly, there's a different set of requirements associated with security and privacy for doing that than there is for driving credit card transactions, across multiple locations, or interfacing with an order entry system, if you will, whether it's at a manufacturing facility or in a hospital where you have personal data. And I think it's very, very important that as we kind of evolve, that there's that distinction that is made. Because what that does is that if it drives everything to a common denominator, quite frankly, there's a heck of a lot of cost associated with driving everything to a common denominator, which is doing it the best, right, and doing it the entire way. And frankly, in the marketplace, it just can't sustain that kind of an infrastructure cost to have to go through that level of rigorous security or privacy if, for instance, you're just passing anonymous temperature set points, as an example, back and forth. That level of requirement is completely different than if it has credit card transactions. So I think that's also very important as we kind of evolve. And as you as consumers, right, and potential customers ask those kind of questions and require those kind of things. You want to comment or no?
Well, one of the things that we tend to look at a lot in terms of the different systems and how they integrate with each other is this whole thing that everybody's kicking around, is the divide between information technology and operations technology. And to a certain extent, what Andy was talking about, the AIC is on one side and the CIA is on the other side. That again, on the IT side, you're worried about, a customer's address, social security numbers, whatever might get out loose, as opposed to, again, the very example about, the incorrect operation of a breaker in a very serious situation can cause, death. In fact, if you have, people on the lines trying to do service work and things of that nature. So it really, kind of in my mind, that's kind of the flavor some of this is taking. And then on top of that, the whole thing about how best to do it. And what we're seeing is, you can spend so much money, you can just, you can spend all the money you can actually come up with and trying to make things so secure. It's really coming up with what level of risk are you willing to take, what makes the most sense, how best to take your money and spend it wisely. And that's one of the things that I think is really starting to happen in the industry right now, is how do I spend my money to get the biggest bang for the buck, and it's largely based on your business.
Okay, the next question, I'll just interject here, is the question I've always had is if we're going to really go to this cloud computing thing, is that what do we do on a clear day? Where does all the data go? Seriously, let's go ahead and take some questions from the audience.
Let me ask a follow-on to
Okay.
what he was
Chuck,
saying.
if you would, say who you are and what your affiliation is. please.
My name is Chuck Trinette, and I work with Mike. And my question really is that I think sometimes with this security, we ought to look at some of the other sides of the security problem. If I'm an engineer in a utility and I want to define a new network, a new grid, a new circuit, I want to know what the usage of everybody is on these various circuits so I can do my job well.
Right.
Now, if I turn around and say, well, that's private information or whatever, and I can't use it or I can't see it, I in fact can do the job that the customer actually wants me to.
Yep.
So we need to be careful about the security in the sense that sometimes we just make the job harder.
Well, and then you're absolutely right. And in the defense business, they call that need to know. In other words, you got to have the information to be able to perform your job, or you're not, like you said, you're not going to be able to do it. So the level of discretion that we use in applying the security is absolutely, a big thing that says, hey, when I don't let my engineers operate the system like they need to, they're not going to be doing their job.
So we talked a little bit this morning at lunch about, try to use an example. Utility feeder might have dozens, maybe less in some cases, points of sensing, right? Or control. If you're in a residential area, you might have a sensor at a cat bank, or just a control point at a cat bank on a pole. You might have 3 or 4 transformers on monitor. You've got feeder level voltage sensing at the substation. We're approaching a point where you're going to have hundreds of sensing points on a feeder, if not thousands in dense urban populations. The biggest difference between where we're at today and that point is that utilities are going to own all these sensing points. If you look at California and the smart inverter proposition that was recently passed, these are autonomous, power factor capable devices. They can adjust for voltage settings and swells, they can adjust for power factor, they can adjust for frequency, right? They can modify their behavior and inject a corrected power back on the line. We don't own these devices as the utility industry, they're consumer owned. Once they're communicated to, what is that security demarc, what is the data that does pass? To your point, the engineers will absolutely need that data, because now you have hundreds of control points and power factor correction points on the system that will impact not just that residence or that underneath that small 35 kVA transformer, but have the potential to move up the line in density. So that is an issue, and that's something that, to your point, utilities, who owns that information? Some of it's a regulatory issue that we have to work through, some of it's a standards issue that we have to work through, and there's a whole lot of it that's network and communication layers that aren't built yet. We can't communicate to all these devices today. And once we start fixing those 3 steps, it's going to be a very real issue. And it's going to be a dialogue point, I think, for years to come, because utilities no longer own all of the devices on the network that need to be communicated to.
Anybody else want to take a shot at that before we?
I believe Tom's got a question.
Yeah, I just want to make sure everybody's through with this one. Go ahead.
Yeah. So having sit through Tom Siebel's talk and then the Dr. Watson, IBM Watson, and you can't help but be impressed with the complexity and the geometric expansion of data and the cloud and all. I come from the energy space, so my biggest concern is where's all the energy to drive this complexity? As we're building this huge dinosaur, I just don't want to go the way of the dinosaur if the fuel runs out, right? So are people thinking about how to support, what is the cost benefit, specifically from an energy perspective, on this increased complexity? Presumably, it is to make things more efficient, and so we actually use less energy. But I'm not certain that that is the case. I don't know. But so that's my biggest concern. Do we have the energy to exponentially grow this computational power that's required if we have hundreds of trillions of sensors and everything is linked? And then the second concern would be, if we do have this Skynet or whatever you want to call it, is there a possibility that some virus gets developed by a nefarious person and it blows the thing up? Is that even possible? But I'm actually more concerned about the energy side.
I'll just say one thing, is that I think your question, Tom, about is there enough energy? The simple answer is yes. The real question, I think, is there enough affordable energy? And if so, what is the mode or the type of that energy? Like take natural gas, for example. Right now, natural gas prices are in the toilet. It's pretty cheap. But that can turn around. I mean, we've all seen probably your home utility, wherever you're from, depending on what type of region you're in. But I mean, in Louisiana, Mississippi, Alabama, Arkansas, that area, in the central south, I mean, I can tell you that all the utilities there, depending on which way the political wind was blowing over the last 30, 40 years, they've had coal-fired plants, They've had gas-fired plants, they've had fuel oil-fired plants, depending on what they were being ordered to do by FERC and by the federal government mostly. And as a result, a lot of the plants have all three capabilities. It's like, okay, which flavor do you want today? Based on things like environmental impact, the cost, per ton of coal or per barrel of oil or whatever. So it's a constantly changing formula. There's enough energy. The question is, at what price? And and when I say what price, I don't mean just dollars. I also mean price to the environment, price to the safety, and well-being of citizenry and so forth. But, your second question, though, I'm going to let Andrew take, as far as, are we going to have a virus that's going to melt down the entire system? I'm sure you have that answer. Take it away, Andrew.
So let me get to that one in just a second. As far as I think energy and computation, you've probably heard the Moore's law that compute capability doubles every 2 years roughly. And then there's Metcalfe's law, which is the power of the network is the square of the memory elements in it. I mean, it's amazing, but we still see continuing shrinkage in the size of processors and the power consumption. There was a look for teardowns of the latest MacBook. I mean, the actual computing component of the MacBook is the size of your iPhone. The whole rest of the thing is battery. So the energy consumption of these processors is going way down. But could a virus blow it up? Well, somebody, we're not really sure, nobody's admitting to it, but built something called Stuxnet a few years back that literally did blow up the centrifuges in the plants in Iran. So yes, absolutely, we have to be be concerned about malware getting into these things and intentionally designed to destroy systems. There's no question that when you can get to the right controls in the end, if you can affect actuators that can disconnect breakers or whatever, you can do damage to physical systems. Yeah.
This is cool. The energy consumption, I'm wondering how the panel might think about the impact of centralization versus distribution of the whole energy architecture on this idea of, well, we got to have all this data. I know we're in substation automation, and one of the things is, well, do you really need every data point coming back to this data center to make a decision, or do you need to know when something goes wrong? You need to change by exception, report by exception kind of logic. And at what point do you sort of have a couple of rules that all these cells are acting under, and then does that decrease the security risks? Does that decrease the computational energy burden? Or, I mean, can you distribute this so it's not one big system, it's a lot of semi-autonomous, self-organizing ones?
That's an interesting point. One of the things that we're seeing, and I'm not one to totally drink the cloud Kool-Aid, as it were, that basically says everything's going to wind up on the cloud. I don't think that's going to happen. There's just certain things, and I think a lot of the things with regard to the Internet of Things are going to drive more and more computational horsepower further and further out to the edge. That you're going to have smarter and smarter devices that are able to peer-to-peer communicate. So that's one thing. Two, the whole thing about cloud computing, a large selling point of that is that you have virtual machines. You have one processor shared multiple ways. It's supposed to use less power. Yeah, we're relying on them to have larger computational calculations, which requires more power, more processors. But in terms of the miniaturization and the power reduction, well, I mean, I'll go as far as to say that I think there's one day that we'll probably see that you won't be using electricity to actually power a computer. It may be light. Those things are actually being kicked around because of the very things that we're talking about here, that you can't sustain it, and actually light's faster than electricity is. So who knows what the future holds. Technology is changing so rapidly right now. I'm not really concerned about us running out of energy to power stuff to do this. I'm more concerned about, about your point, about how much data is enough. In other words, the whole concept about scanning a circuit breaker in a substation every 10 milliseconds, as opposed to having it just when it has a problem, it sends out a signal, and changes state. And those real smart ways of actually, using the data in the right form and kind of gets back to the point of, you know, how much data is enough data, what do you need to actually operate your business? And so we're gonna have to take a real hard look about just, you know, the data itself and how much do we actually need.
Yeah, I wanted to expand on that, because that's one of my bugaboo. We can generate data from smart meters now. We can record your usage every 5 minutes, or maybe down to even every second. And
Every
we can
second.
store all that stuff and generate ourselves a big data problem. What do we need all that stuff for? Do we really need to keep that for very long? Flip side to that is, well, half the world's data centers are storing pictures of cats, so.
I just want,
There's the two codes.
That's great.
there's another element to this too, and I'll say that it's not just the data itself that's coming in, it's a transport mechanism to move the data around.
Mm.
And-
Right.
And I'll say, and I'll use,
Absolutely.
our photographer back in the corner has a great widget on top of his camera. This microphone itself is probably the best example I can use. This device has more rights to use of spectrum than a utility. Okay, so it's serious. This device, the manufacturer of this device, has access to spectrum that's codified and carved out for the use of this device. Right? Utilities have zero spectrum, not one. Now they have access to spectrum, but none of it is dedicated to the use to manage these systems that's delivering the most critical assets of our commerce and lifestyle, which is energy and water. They're intermixed. You don't have water without energy, unless you're hand pumping, and not many people want to do that in 2015. So when you look at sustainable activities, it's what utilities have done has been incredibly efficient at moving data around and what data needs to go, command and control signals, what pathways to choose, how to architect a communication network that, quite frankly, is everything stacked against the success of that network. So I think long-term, we need to look at a couple things. I do think the power's there, right? The average consumer uses far less power than they did, even though they're adding more devices in their homes. And the average business is, I mean, they're tanking fast in the power consumption over square footage and occupancy. These are sustainable activities. We're in our 4th generation of lighting technology in the last 25 years with LED. And we'll see another one in the next, if you think LED is the end of it, you're probably gonna lose that bet. So you're seeing all these activities go on. But ultimately, the use of the ability to transport data and to move it around to take that next revolutionary step in utility control and automation is going to be limited by the networks deployed. And what you're doing in substation automation is that commendable piece. You're making you're making decisions local, but at some point you have to deliver information back to the mothership for either assessment, analysis, emergency control, because that substation may not know it needs to go offline. Right? It may not know that it needs to start pumping data in when the hurricane's coming at a higher rate. All right? That substation doesn't know it needs to be told, and the data has to come back. So if we don't fix the fundamental formula for making sure the utilities have access to the data pipelines that they need to go from 2015 to 2050 and beyond, we're playing a very tough game.
I would say, I think, good points for the other thing to keep in mind too with the data piece is don't forget the concept, and it's not even a concept anymore, but the reality of machine learning, right? The reason you have all the data today is to basically develop, right, those models and begin to actually get to the point where you have self-learning. And when you have true self-learning, even down to substation level, that is where you will actually see the requirement for the data fall off, right? Or it will top off and flatline from that point forward. And that machine learning becomes a tremendous value potential to reduce the power costs and those kind of things for all the sensors and everything else. And we haven't reached that phase yet, but we're actually not all that far away from that either, where you actually have the level of intelligence that's there at the device. And of course, then that's where people get all concerned about artificial intelligence and all those kind of things. But that is the reality that stops all the data flow from having to just go not astronomical, but keep going logarithmic.
I was just going to mention that, as I said earlier, I'm an old SCADA guy, and SCADA, for those that may not know, is supervisory control and data acquisition, which is just a sophisticated way of saying data acquisition and control, or measurement and control. I can tell you, I mean, further to Andrew's question about, why do we need to gather all this data? Having been doing this for 40 of the 42 years, we've spent basically as an industry, and not just the utility industry, but the energy and utility industry and a lot of other industries as well, gathering as much information as we could, as fast as we could, because little known fact, right now, today, over half of our critical infrastructure, the RTUs, remote terminal units, the data gathering units, control units, and substations, pump stations, compressor stations, et cetera, are still communicating over unconditioned voice grade circuits. That means 2400 baud, 2400 bit per second communications, when, as a friend of mine from Energy once said, you wouldn't be satisfied to surf the net in your living room with. And yet that's what runs our critical infrastructure. So the point I'm making here is that for the past 42 years, it's pretty much been a consistent push the technology, push processor speeds, push processing capability and communications bandwidth. The first systems I did were operating, SCADA systems were operating 15 baud over DC loops. Okay, you could almost carry the data faster than that and put it in the bucket. Since then, I mean, we've obviously come a long ways. I mean, now we are able to gather huge amounts of data, and we've reached an impasse because there are several places where we have siloed data. For example, substations are a good example. Any modern microprocessor-based relay, protective relay, worth its salt, can store anywhere from probably 5,000 to 10,000 data points that are what we call non-operational data. In other words, it's information on power quality, flicker, microflicker, things like that, sinusoidal, data that's being retained. But until recently, there's been no pipe to get that out of the substation, because the substation communications at 12 or 2400 baud is doing everything it can do just to be able to meet the 1 second update time that's required by electric utility substations. And there isn't anybody putting multiple lines into there in most cases because it's horrendously expensive. And so the point I'm making is that for the past 40 to the last 42 years, most of what we've been doing is trying to get as much as we can as fast as we can. And like a lot of other things we've been doing for decades, that's a habit we have to break, because there really isn't a need to do that anymore. We have the ability to gather enormous amounts of data, and we shouldn't be doing it just because we can. So I think it requires a little bit different thinking from what we've been doing.
One element from sustainable security models, also asset security, right? Are your assets, do you have the assets necessary to ensure operations? You brought up your old log lines. All of your utilities are getting phone calls randomly throughout the year saying, yeah, you know that copper line is gone in 6 months, right? What do you mean? Yeah, that 20-mile run that you have out to the substation that's up in the hills that you go to once a week, or, yeah, we're going to cut that line, and so we're not going to support it, it's gone. And so our utilities are being faced with there's an inflection point, a very significant pain point in utilities right now on securing the right networks, securing the network transport for this data in many critical paths. So it's something that they're working very hard on, but realize that supply chain security is also an aspect of utilities' lives. Securing, they don't own all of their comm lines, they don't own all of their contact, all of their IT resources. They don't own, it's cloud asset as well as cloud computing at this point. But that's a very real issue, and we need a secure utility needs to be able to provide a secure environment. Many of these communication technologies also, the security headroom required on these new transport protocols are outpacing the ability of you can't run the new security headroom over copper. It just cannot be done.
And then you put 6180 inside it, it's like.
Right.
Oh, yeah.
Now, is that detrimental if it's a dedicated line, T1 line? What is the actual risk? It's a risk mitigation issue. So as we move into these new platforms, these new secure environment platforms, the standards, codes, and what have you, new technologies, we also have to have. That's why I stress the need of the comm pipe itself. We talk about big data, we talk about all this, but as an industry, we haven't talked enough about the transport layer and the incredible amount of work that goes into just making it work today, let alone getting where we need to be in 2050. We have a lot of fiber, a lot of RF, and a lot of duct tape and baling wire to get this thing working again.
Any other questions?
I think there's something that I never hear very much about because of all the concern of the big data and the whole variety about that. To me, cloud computing, the advantage of cloud computing is that I can get to applications and processes that I could never get to before. part of that's like a home licensing issue. I can buy one copy of this software and I can access it on any computer I want to access it on. That's all cloud. That's part of the cloud. And I think that's true of these pieces of equipment that I want to use I want a lot of data to come in and to do a lot of processing and to turn the switch on or off, whatever control guys do with all
Yeah,
this.
you can run a complex algorithm without having on a crazy computer.
Right, but on the other hand, why don't I just collect that data, move it to the cloud, and then use a big computing application that considers more than this one that was programmed 20 years ago, and handle that overall better. Now, that's not so much the data cloud, that's the application and the distribution of the application. I don't know if there's a question. The question is can we look also at the impact of the applications in this consideration about whether we want to move to the cloud and what we want to move to the cloud?
I would say, if we,
That was actually one of the questions, so that's a good one.
It is good, yeah.
Came up,
I think, so the simple comment is that, and again, I have perhaps a biased comment, but I think it's less about the data, because the data and the storage of the data, forgive me, is cheap, right? I mean, it is, it's relatively inexpensive. The value and the benefit of what I'll call more virtualization versus cloud is the fact that you can actually run those applications and you can get the benefit of those applications and the horsepower, et cetera, required to actually solve significantly complex problems that not that long ago you couldn't without the big supercomputer in the corner kind of thing, right? And the other piece that does is then it opens up the opportunity, quite frankly, for more difficult problems to be solved by many more people. Versus them having to go to a central point and solve it in a central point because that's the only place that's got the computer, right? I mean, it's a very simplistic view, but I mean, I think that's really what you see is the proliferation of the applications are moving to the cloud. I mean, look at even the advent of Microsoft's 360, right? Their Office 360 environment. I mean, you're accessing those applications virtually. And that is where, in my business or our business, that's what it's all about, right? Our application is in the cloud, and the value of having it in the cloud is the fact that we can deliver it simultaneously to thousands of locations. Whereas at a very inexpensive price point. And like it or not, I mean, I think the dollar at the end of the day drives a lot of the decision processes, right?
That's right.
And it's not as simple just, hey, it's 50% less. I mean, it's hundreds of percent less in terms of cost, and then it provides you have so much more access to the marketplace, and so many more users are now available to access it as well. So I think that is absolutely what drives it more so than a data piece.
it's all about the app mentality.
Right.
If you look at some of our co-op members have access, there's a cadre of developers that develop applications specifically for the co-op community, the co-op electric community. Great companies, great organizations, in some cases are consortiums of co-ops that develop common apps, common platforms. So a utility that might have 9 technical resources internally, IT slash telecom technician slash the computer programmer, he or she has access to an app that they couldn't develop internally or probably source internally from one supplier. The benefit also being that app replicated across all the co-ops is also up to date. There's a Mac up there, there's a Dell up there. What service pack are you guys on? Do you know? If I asked you without looking, right? The answer is probably no. My Mac has about 42 apps embedded in it. I don't have to worry about my service packs and all that. The reality is, it becomes a risk assessment. If I have an application that's critical to my business, whether it's operational or communication to customers, or just asset management, right? If there's a quality program, quality application that I can leverage in the cloud, it's a supply chain choice. Right? It becomes a supply chain choice, and it's the easiest way to provide a secure atmosphere. It's a win.
Now let me give you some information in that regard. One of the things I mentioned right up front that we recently done a study regarding cooperatives, and several of the guys you probably are referring to, we use this part of the vendor survey. It's really interesting in that regard, in that the vendor community and this is really where you see a dichotomy, and this is one of the things I wanted to throw out to see if anybody else would experience the same difference of opinion, as I'll put it, is that we see 80-something% of all the vendors that we survey are absolutely committed to move almost every application that the utilities use to the cloud. They see that happening in the next 10 years, no, 5 years. The co-ops, on the other hand, less than 20% said that they had any plans to actually move things, and there were certain things they were never going to move. So you've got a real dichotomy between the industry right now, and it's all about something that came up this morning. Trust is about, you know, how can I trust this stuff? How do I know that what I'm getting is going to be, you know, good? It's not going to do something bad. I'm not going to basically subject my business, because I can tell you some of the executives, they're not going to let, you know, their systems, even though their business is keeping the lights on, they still don't feel comfortable by having their companies at risk, because all of a sudden they've lost control of the systems that they used to have in-house. So this is another thing about, you know, there's this, I believe, a hybrid that we're going to see of a mixture of cloud where it makes sense, and then you'll see also machine to machine, a proliferation of that to support this Internet of Things and more sensors. And then you're going to see some things in the middle, like I honestly don't think you'll ever see SCADA on the cloud. I really don't. I don't think that anybody's going to let that go, because there's too much, you know, you're betting a company on that kind of stuff when you let it out of the house.
Sure, I do know some SCADA vendors who are putting SCADA in the cloud.
I know.
Personally, if I ran a utility, I'm with you, I would not put a control application in the cloud. There are a bunch of things I absolutely would put in the cloud. There's, for instance, transformer monitoring and turbine monitoring and so on, where because you're getting data from a big set of systems, more so than just your own local utility, you can run algorithms and look for patterns across that bigger data set. In fact, that's the cloud service that we are building right now is a cloud service that looks for data patterns of cybersecurity attacks across a big set of customers, and we think we can build it better defense that way. So I think there's certain applications that absolutely make sense in the cloud, but some, especially the very local control ones, that I would keep away from the cloud.
Okay, we have a postscript.
Just a postscript.
I would reinforce exactly just the concept of the control being local, but there is always the opportunity, because there is more dynamic data that's out there, to essentially have the ability to optimize that. So there's nothing wrong with essentially maintaining the control, whether it's SCADA or whatnot at a local level, but you always have the ways to actually optimize that with data input and information from outside coming back inside. And that actually can improve, you know, it still keeps everything inside the four walls, for lack of a better way of saying it. But by keeping it inside the four walls, you don't circumvent anything, you actually maintain that continuity, but you're providing an input to it, whereas historically that's never happened before. You're never historically looking to provide some type of override input to it based on more dynamic data streams. And that's really what I think is ultimately all about what can happen as we transition to this next phase of optimization / sustainability, cloud, virtualization, whatever it might be.
Okay, so was there one more question here?
I was just gonna ask about the spectrum that you were talking about. You know, utilities have transmission lines and things like that, and you're saying that utilities right now don't own the spectrum?
I would say utilities can license spectrum on the open market, purchase blocks, right? When you look at, okay, Austin Energy, let's just say that there's a hurricane in Texas, right? Your systems are yours, you're islanded, so you're you know, all of the, you know, if folks come into Texas to assist, they're working on your license, that, you know, that you own that specific slice. If you look at most critical infrastructure industries, right, there are bands that are dedicated to service, right? So that doesn't exist in the utility space. So manufacturers are forced to use things like unlicensed, which is increasingly crowded space, right? It's coming under fire from new applications like location monitoring services for 911 and some others. There's always going to be pressure on spectrum. It's a finite resource, and it's critically important. utilities as an industry, our infrastructure does not have spectrum available as primary use for the service of delivering power and energy services, right?
Would ERCOT have that spectrum? No.
You can license available spectrum for purchase. There are organizations that have it, that will sell it to you as in a defined geography or territory or what have you. It's quite a battle, and it's actually one that I think the utilities are rapid, particularly with the end of TDM services and copper lines and the need to go to more wireless-based services, having deployed billions now in assets and wireless services and various frequencies that will become more crowded. It's a real issue, and I think it's something that we need to focus on.
There actually was an allocation exclusive for utilities about
Canada
15,
doesn't have-
20 years ago with the 980 or 928.
It's something, and it's actually,
over with.
it's something, we can talk about it more, but
Yeah.
it's
We can
very-
continue afterwards if we want to stay, but we have to close it out here, so thank you to all of our panelists. This is round of applause. And we'll be back maybe next year.